Hi everybody, this is the third part of this subtopic parallel line and perpendicular line. So in the previous video, I discussed until example number 8, right? Okay, so now let me continue example number 9. Determine whether the straight line, okay, now I have two straight line over here, which is 4y is equal to 3x plus 8, and another straight line is x over 3 plus y over 4 is equal to y. Are they perpendicular to each other? So I hope that you remember, if the product of their gradient m1 times m2 is equal to -1, then they are perpendicular to each other. So since we know this concept, so now I'm going to get the gradient of this straight line and the gradient of this straight line, and then I will multiply together, find their product. If they are equal to -1, that means they are parallel, they are perpendicular to each other. If it's not, means that they are not perpendicular to each other. Okay, so now let me get the gradient for this straight line first. 4y is equal to 3x plus 8. Always be careful. Don't say that the gradient is equal to 3 and the y-intercept is equal to 8. It's not correct. Remember, if you want to get the gradient and the y-intercept, right, make sure the coefficient of y here is 1 and positive. Now this is already positive, no problem, but the problem is this is not 1, right? So what we need to do in order to make the 4y become 1y, we will just divide this whole equation by 4, right? Okay, so 4y divided by 4 you get y, and then this divided by 4 you get 4 over 3x, and then 8 divided by 4 you get 2. Okay, now the y here is positive and 1. Okay, nothing here means 1. From here we know the gradient is equal to 3 over 4. Okay, now how about this? X over 3 plus y over 4 is equal to 1. This is intercept form. This is for x-intercept, this is y-intercept. Okay, so let's say if you have another straight line, negative, let's say this negative 4 is equal to 1, right? So this is intercept form as well, but you have to be careful in this case. The x-intercept is 3 and the y-intercept is not 4. It is equal to -4 because this is actually equal to this. Okay, this is a y-intercept, this is a x-intercept. So be careful. In this case, don't say that, don't think that the y-intercept is 4. It's not correct. You have to put -4. Okay, so in this case, no problem because this is positive. Okay, so the gradient will be equal to negative y-intercept. I hope that you still remember this formula over x-intercept. So it's -4 over 3. Okay, I don't need to continue anymore. So -4 over 3. So now I want to test the m1 times m2. Is that equal to -1? If they are equal to -1, yes, they are perpendicular to each other. If it's not equal to -1, they are not perpendicular to each other. So I'm going to test now. Okay, so we just simplify it. We get 1, 1, right? So just simplify it. You get 1, 1. Okay, now you have a negative. You have a negative here, so it means -1. Okay, since they are equal to -1, since the m1 times m2 is equal to -1, therefore they are perpendicular to each other. Therefore, they are perpendicular to each other. Okay, so this is a way how we test whether the two given line are perpendicular to each other or not. Okay, now let's look at example number 11. I have a parallelogram here. When you see parallelogram, you know that these two sides, they are parallel to each other. They have the same gradient. And these two sides, they are parallel to each other. They have the same gradient as well. Okay, so this and this same gradient, this and this and same gradient. This and this gradient difference. Okay, now let's see what the question asks us. The gradient of PQ, we want to find the gradient of PQ, means that we are looking for the gradient for this straight line. Okay, now we have the coordinates. I think should be no problem, right? y2 minus y1 over x2 minus x1. The gradient of PQ is equal to y2 minus y1. You can take 6 minus 18 or 18 minus 6, up to you. 6 minus 18, but if you take 6 minus 18, the bottom here, you have to follow the sequence for minus negative 6. Okay, be careful when you see a negative. And remember, y on the top, x at the bottom here. Now, before you find, right, you know the answer must be negative. Why? Because you look at this line, you know that this straight line is going downward like this, definitely it will be negative. If you get positive, means that we make some mistake, we have to double check again. Okay, so this will give you negative 12. Negative will become positive, so it becomes 10. So we just simplify it, divided by 2, divided by 2. Okay, let me check, not this. Okay, so correct. So I would suggest you to label the answers here. So maybe in the next part we need to use it. PQ, negative 6 over 5. Okay, now we want to find the equations of RS. RS, where is RS? Okay, so RS over here. Okay, so always remember, if you are asked to find the equations of a straight line, right? Always look for two informations, gradient, which is m, and 1 point. Okay, now we have 3 points over here, this, and this. Which point should I use? Remember, the point that you use must lies on the straight line that you want to find the equation for. In this example, I'm going to find the equation for RS. So definitely I need to use the point which fall on this straight line. In this case, I cannot use Q, I cannot use P either. What I can use is only here, R. Okay, so do I have the gradient? I don't have the gradient. So how do I get the gradient? You might be thinking, we use this formula, right? y2 minus y1 over x2 minus x1. But the problem is, we need 2 points. Now we only have 1 point. We don't have 2 points over here. So we are actually not able to get the gradient of this straight line using this formula. But don't worry, because the questions tell us that they are parallelogram. This and this parallel, this and this parallel. Parallel means that the gradient will be the same, right? So the gradient of RS will be equal to the gradient of PQ, which is equal to negative 6 over 5. So now we got the gradient. What's the next thing? We need 1 point. We just use this point to help us to get the equations of this straight line. You can use y equal to mx plus c to help you to get the equation of this straight line. If you don't want, how about we try another new formula that we have just learned, which is y minus y1 is equal to, okay, let me use back the red color. Y minus y1 is equal to m x minus x1. So for at the beginning, I would suggest you to write this equation for a few times so that you can remember it well. So now I know the gradient is negative 6 over 5. Y minus y1 is equal to negative 6 over 5 x minus x1. Now I'm going to use this point to help me to get the equation. At point PR, which is negative 4, 8. This is y, this is x. So now I'm going to plug in this y over here and x over here. Okay, so y minus y1 is equal to negative 6 over 5 x minus x1. Okay, I think I changed the parentheses here. Okay, so next thing is just to simplify this thing up. Okay, so y minus, okay, let me draw a line so you won't look so confusing. Okay, so y minus 8 is equal to negative 6 over 5x. Okay, just do some expansion. Okay, I think I do it this way so easier for you to understand. Negative 6 over 5 first, just copy this whole thing first, and then x plus 4. Okay, negative will give you positive, then only we start to do some expansion. Negative 6 over 5x, negative positive will give you negative 6 over 5. Okay, now next thing is to move this over here. Y is equal to negative 6 over 5x minus 24 over 5 plus 8. Okay, so here you can just press your calculator. Okay, 保是 okay, let me check actually 5. Okay, let me check around now. Negative 24 over 5 plus 8. Okay, so sorry, should be 保是 should be positive over here. So you can stop here. If you don't want, some students they don't like to see the fraction like this, you can just multiply the whole equation by 5. You get 5y and it's negative 6x plus 16. Okay, you can stop here if you don't want to continue to this step. Both are correct. Okay, now let's try this in an example. The diagram above shows a rhombus. Okay, when you see rhombus, you have to know the characteristic, the properties of a rhombus. All same length, right? Here, all same length. And they are parallel to each other. These two parallel, same gradient. These two sides parallel, same gradient. And then don't forget, okay, that one I tell you later. Okay, now focus on part A first. The gradient of QS. Okay, so now I'm going to get the gradient of QS, which is over here. This is too thick, right? Let me use this. QS. Okay, so I need to use this point and this point. The gradient of QS, y2 minus y1 over x2 minus x1. Remember, y on the top and x at the bottom. 6 minus 10, if you don't want, you can take 10 minus 6. Okay, how about I try 10 minus 6. If I use 10 minus 6, for this part, I have to follow the sequence. Negative 1 minus negative 3. Minus 3. Minus 3. So before I calculate the gradient, I know that my answer should be negative. Why? Because this gradient, this line is going downward like this. Okay, so here will give you 4, this will give you negative 4, which is equal to negative 1. Okay, so now I know that this is equal to negative 1, the gradient. So now let's proceed to part B, the equation of PR. Okay, PR is over here. This is PR. Always remember, if you want to find the equation of a straight line, always look for two information: gradient and one point. Remember, the point that you use must lies on that straight line. So I have 3 points over here. Which point should I use? You can only use this point, because Q and S, they are not on this straight line, so you cannot use it. You can only use this point. But the problem is we don't have the gradient of PR. How do I get the gradient of PR? Okay, I hope that you still remember one of the properties of a rhombus is the diagonal are perpendicular to each other. Since they are perpendicular to each other, you know that the gradient for, okay, let me write over here, the gradient of QS times the gradient of PR is equal to -1, right? Since that they are perpendicular. Okay, so gradient of QS we know, which is -1 times gradient of QR or PR. This is PR. Is equal to -1. So now we should be able to get the gradient of PR easily just by taking -1 divided by -1, which will give you 1. So now you have the gradient, you have the point, you can get the equation easily. Okay, how about I write the formula for fill time first? Y minus y1 equal to m x minus x1. Okay, write this formula for fill time before you start solving it so that you can remember this formula well. Okay, now I know that the gradient is equal to 1. I'm going to plug in this onto this formula. Y minus y1 is equal to 1. X minus x1. So the 1 here, actually you don't have to write, it's okay. You don't have to write 1 in front of this parentheses. People know that there is a 1, is okay. Now, 1 point, right? So remember, we can only use a point that fall on the straight line that we are going to find the equation for. So at point R, 5, 12. This is y and this is x. The y I'm going to plug in here and the x I'm going to plug in here. Okay, y minus y1 is equal to 1. Okay, we don't have to write the 1, it's okay. X minus x1, which is equal to 5. Okay, so we try to rearrange all this nicely. X minus 5 plus 12. So y is equal to 2x plus 2x. Oops, sorry, not 2x. Should be x. I'm a little bro. Okay, so this is x. So this is 7. Y is equal to x plus 7. Okay, so this is the answer for this question. Okay, so for this video I just stop here first. Hope that you understand better after watching this video. So remember, you need to try on your own, then only you can master it well. Okay, thanks for watching and see you next time. Bye bye.